Hello everyone. So in these videos we're going to look at some examples related to the problems you need to do in this set, in problem set 2. So mainly in this problem set we're looking at drawing a situation. Sometimes you can physically sort of make a drawing or just sort of picture it in your head. I really recommend that you draw. That's probably the best thing that you can do for yourself. It really helps organize the information and writing some equations and getting started. Okay. And like with everything, it's a process that you get familiar with and you get better over time. If you haven't solved many word problems or made sketches, then it might feel a bit awkward at the beginning, but you get better and better as you do more, like with everything in math, right? So let's look at this problem. So Michael and Aaron are running towards each other, beginning at opposite ends of a 10,000-foot airport runway, as pictured in this figure. And we want to know where and when the guys will collide, all right? So the picture also gives their speed. So Michael is running at 15 feet per second, and Aaron is running at 8 feet per second, and they're running towards each other. Okay? So when doing problems like this, it's good, not necessary, but really good to impose a coordinate system. So this is kind of one of the main topic of these problems is imposing this coordinate system. So let's look at this situation, and to impose a coordinate system, we want to decide where the origin is, and then sort of x and y axes. So you could put the origin in any location. Some make more sense than others. Okay? So let's put the origin where Michael is. So we're going to put the origin right here. Right? So I'm going to draw y-axis. I'm going to draw the x-axis. Alright. Okay, let's see if I can do a little bit better than that. There we go, like this. So x and y. Alright, so really it's not a two-dimensional system because you're only moving in the x, but that's okay. Kind of having your x and y there is very handy. Alright? So now let's follow Michael and Aaron along. Okay? So we can see that Michael, his starting point. So Michael, he starts at 0, 0. Alright? And Aaron, he starts, because they're 10,000 feet apart, he starts at 10,000, 0. So these are their starting locations. Okay. Now let's see what happens when you kind of start the time. Okay, so you go ready, set, go. They start running. You start the time, and they start moving towards each other. So Michael's distance is changing at this rate because he's moving 15 feet per second. So his location. So the x value is going to change like this, 15 times t, and the y value still stays 0 because he's not jumping up, all right? So 15t comes from, right, rate times time. So distance equals rate times time. So his speed times 1 second, 2 seconds, right? So a second later he's at 15 feet, another second later he's at 30 feet, and so on, okay? Now let's look at Aaron. So Aaron is moving in the opposite direction. So his x values are getting smaller because he's sort of getting closer to the origin. So you need to subtract. Okay, so he starts at 10,000. And you need to subtract how much he's covering. So each second he's covering 8 feet. So you're going to subtract 8t. And again, y value is 0. Okay, so this gives the position of each of them at a particular point in time. Okay, these are called parametric equations. Right? You sort of having your x and y coordinates in terms of time, in terms of t, and you will encounter these a bunch in our course. So this in this part we imposed the coordinate system and we wrote equation for the position of each with respect to time. Okay? All right, so now that we did the setup, we can answer the question. So where and when will these guides collide? So they're kind of moving, fast forward in time. He's moving faster than Aaron, so they're probably going to meet more than halfway. So definitely like 5,000 feet is halfway. He's going almost twice as fast as this. So they're probably going to meet around the 2/3 point. So they're going to meet somewhere here. All right, I say give a high five. All right, so to work with the equations, we so this is the x and y coordinates for Aaron. This is the x and y coordinates for Michael. So this is Michael and this is Aaron. All right. So they're going to meet at a particular x coordinate. So you want their x coordinates to be equal to each other. So we have 15t equals 10,000 minus 8t. Okay, and we solve, and that will give us when, the time that they will meet. So we have 23t equals 10,000. So t equals 10,000 divided by 23. All right, 10,000 divided by 23. So this is 434.7826 seconds. All right, let's change this to minutes because it doesn't make sense to kind of go, oh, I'm going to meet you 434 seconds later, right? You want to change them so they kind of are real usage. So time equals 7.24625 minutes. Oh, wow. All right, so they're running quite a bit there. All right, so that's the when. All right, now let's see the where. When and where. So the where is going to be in our coordinate system. We figure out x. Okay, so we can plug in either of them because they should give us the same value, because that's how we found that time, by setting them equal to each other. So we have 15 times 434.7826. Notice that I'm putting my time in seconds in here, so it's convenient to express your answer in minutes, but to match the units, right? Because your speed is in 15 feet per second, you want to use the time in seconds, otherwise you're mixing units. So 434.7826. This is 6,521.74 feet. This is from Michael's original position. Okay, so how we set our axis was arbitrary, though. I put my origin here, so you can basically, in your answer, you can sort of explain what that distance means. Okay, good. So here is our answer. Excellent. All right, so let's look at this example here. So two cars depart from a four-way intersection at the same time, one heading east and the other heading north. Both cars are traveling at a constant speed of 30 feet per second. Find the distance in miles between the two cars after 1 hour and 12 minutes. In addition, determine when the two cars would be exactly 1 mile apart. All right, so we got to sketch and impose a coordinate system. This will kind of start us along. Okay, so we have a four-way intersection. Right, so basically, let's say we have roads going like this and like this. All right, so that's a four-way intersection. One is heading, so we have two cars. So one is heading east. So let's get our axes. So I'm going to put X and Y axes for the origin to be in the middle of those intersections. Have the origin be here. All right, and if we use these to kind of the traditional compass points, right? We have north, south, east, and west. All right, so one car is heading east and the other one is heading north. Okay, so one car is going this way and the other car is going this way. All right, so they're both starting at that intersection, but they're moving, and they're moving at a speed, equal speed of 30 feet per second. Okay. All right, so let's look at, it says, find the distance between the two cars after 1 hour and 12 minutes. So because they're moving at the same speed, they're going to travel the same distance. So kind of say on our sketch here that after 1 hour and 12 minutes, the first car is here, and then the second car is here. So this is car A and this is car B. All right. Find the distance between the two cars. So we need to figure out how far apart they are. So finding the distance between them. We got to figure out what this is. All right. So you can see our approach here. Okay. We can use a little bit of right triangle trigonometry. This makes a right triangle, right here. We can use Pythagorean theorem. Or another thing that you've been learning is this chapter is the distance formula. Okay, so, and the distance formula is basically just a rewriting of Pythagorean theorem using in a coordinate plane. So let's look at the distance formula. So if you remember, this distance formula says the distance between 2 points in the coordinate plane is x1 minus x2 squared plus y1 minus y2 squared, and then take the square root, okay? And it doesn't matter how you're subtracting, because of the squaring is going to make it always positive anyway, so it doesn't matter which order you're subtracting, all right? So x1, y1, x2, y2, they refer to the coordinate points of the cars. Okay, so let's figure out where car A is. So I'm going to use the dirt equation because we have a rate and a time. All right, so the rate is 30 feet per second. All right, and these two D's are different from each other, so I'm just going to not write it there. And I want to multiply by the time, which is 1 hour and 12 minutes. 1 hour and 12 minutes. Right? But this is not a good multiplication, right? Because the rate is in feet per second. The time is mixed units, 1 hour and 12 minutes. So we want to change this to seconds. Okay, so there are 3,600 seconds in 1 hour. And then 12 times 60, there's 60 seconds in 1 minute. So 3,600 plus 12 times 60 gives me 4,320 seconds. Right? So we have 30 feet per second times 4,320 seconds. We get 129,600 feet. Right? And we want to have our distance in miles. Okay, so 1 mile is 5,280 feet. So we're going to divide by 5,280. And we get 24.545454. 55 miles. All right, good. So this point A right here, the x-coordinate is 24.55 and 0. And this point right here is 0 and 24.55. So here the x-coordinate is changing here the y coordinate because it's moving along. The car is only moving along x and car B is only moving along y. Alright, so if I take this to be my x1, y1 and this my x2, y2, I can figure out the big D, which is the angular distance between them. Alright, so let's see. We have 24.55 minus 0 squared and 0 minus 24.55 squared. Alright, square, add, take the square root. You can do it all in your calculator. 24.55 squared plus 24.55 squared. And I got 34.72 miles. Alright, so 1 hour and 12 minutes later, they are 34.72 miles apart. Alright, second part of the question. In addition, determine when the two cars will be exactly 1 mile apart. Alright, so let's see how we can figure that. Okay, so and now it's like when. Okay, so I know for car A. Alright, so car A is moving at 30 feet per second. So for each second, so for car A, the x coordinate is going to be 30t and the y coordinate is going to be 0. For each second it moves, you add another 30 feet. Okay, so it's 30t. Car B is going to be on the y-axis, so 0, 30t. So this parametric equations, really handy. Alright, so again using our distance formula here, we want the distance to be 1 mile. Okay, so let's put things in feet because this is 30 feet per second. So 1 mile equals 5,280 feet. So we want 5,280 feet to equal to square root of 30t squared plus, subtract these, negative 30t squared. So this is going to be 900t squared plus 900t squared, which is equal to square root of 1800t squared. Alright, so now take square root of both sides. So 5280 squared equals 1800t squared. T squared is 5280 squared divided by 1800. So t is going to be square root of 5280 squared divided by 1800. Alright, just use your calculator to figure that out. And I got 124.45. And what are my units? My time was in seconds, right? So my units is in seconds. So that's how it kind of determined, because your rate was 30 feet per second. You wanted to use your distance to be in feet and your time ends up being in seconds. Okay? If I want to change that to minutes, you divide by 60. So you get 2.07 minutes. There we go. Okay, and that's it. Alright, so welcome back. Next thing we're going to look at are some basic curves. Okay, so first of all, horizontal and vertical lines are good basic curves that we're going to encounter over and over. So horizontal lines are of the type y equals k, so y is a constant, right? So this will, when you graph them, right, they're going to go straight across. So this is an example of a line y equals a constant. And a vertical line is x equals a constant, x equals h. So this is a graph, an example of a vertical line right here. Okay. The other curve that we're going to encounter over and over again is a circle. So a circle in the coordinate plane. You have a center denoted by a coordinate point. It's typically called h, k, the x and y values of the center of the circle. And there's a radius. Okay, so a circle is all the points that are that distance away from the center. Okay, so a random point xy on the center is going to be a distance of r units away from the center. So using the distance equation, you can derive the equation of the circle. So x minus h squared plus y minus k squared equals r squared. This comes directly from the Pythagorean theorem and the distance formula that we used not long ago. Okay, so some of the problems that you're going to encounter in this problem set will have to do with intersections of horizontal and vertical lines and circles. Okay, so whenever you ask to find intersections, you want to plug equations into each other to figure out the intersection points. Okay, so you can see in this first scenario, you can have, if I have like a couple of horizontal vertical line and circle there, you can see that they're intersecting 3 points. Okay, 4 points, and you can find those intersections by plugging the equations into each other. Or sometimes they could be like tangent, but you still find the same way. Sometimes they don't intersect, and if you plug equations into each other, they don't intersect, then you get no solution. So there's no intersections. All right, so let's look at an example that kind of goes along with these. Okay, so basically you want to be familiar with the equation of a vertical line, a horizontal line, and that equation of the circle. All right, so Glowtech Industry has designed a new halogen street light fixture for the city of Seattle. According to the product literature, when placed on a 50-foot light pole, the resulting useful illuminated area is a circular disc 120 feet in diameter. Assume the light pole is located 20 feet east and 40 feet north of the intersection of Parkside Avenue, a north-south street, and Wilson Street, a east-west street. What portion of each street is illuminated? All right, it sounds like we want to impose a coordinate system, coordinate axis here. So let's draw xy axes. I'm much better at my x-axis than my y-axis, aren't I? All right. So because we have the north, south, east, west, this is north, this is south, this is east, and this is west. Those are cardinal points. Okay. So it tells us the location of where this light pole is. So the light pole is located 20 feet east and 40 feet north from the intersection. So this is the intersection of the two streets. Okay, so 20 feet east. So if I go 20 feet east, so say each of the markers is 10 feet, and 40 feet north. All right, this is where my light pole is. And now this is in 3 dimensions. We don't need to draw the third dimension, but imagine the light pole is kind of coming towards you. All right, so there's a light pole here that you're looking at the top of the light pole. Okay, and that light pole is 50 foot high, but I don't think it matters in this problem because it kind of tells us the illumination region. This part is irrelevant right here. We don't need that. Okay, so it says the resulting useful illuminated area is 120 feet in diameter. All right, so that means the radius is going to be a circle, and the radius of that circle is going to be half of the diameter, so it's 60 feet. All right, so if I draw a circle with a radius of 60 feet, you can see, this was 40 feet, so I need to go a couple down. So go 6 up. All right, and we go 6 this way. Now we go 6 this way. I'm trying to kind of make it to some sort of scale. It's not necessary to make it to scale, but I think it's really helpful. Alright, so this circle inside the circle denotes the illuminated area. Alright, so let's fix this a little bit. I made it worse, didn't I? So yeah, the light pole is right here, and the light is shining, and it's illuminating this circle area right here with the radius of 60 feet. Alright, so what is the problem asking us to do? What portion of each street is illuminated? Okay, so it's basically saying, what is the range of values on the x-axis, and what is this range of values on the y-axis? So not like a ratio or anything, or a percentage, because you don't know how long the streets are, but within this coordinate system, kind of what are these values of x and what are these values of y, the intervals. Okay, all right, so we can see that we have a horizontal line that intersects the circle, and this east-west line, this is the equation of y equals 0. Okay, so this is a horizontal line, y is a constant, and because it's passing through the origin, this is y equals 0. Now the north-south line, this is a vertical line, and the equation of it is x equals 0. Again, it's vertical, so it's x equals a constant, it's going through the origin, so x equals 0. Okay, so to figure out these intersection points, we gotta see where the circle and the horizontal line y equals 0 intersect, right? So what is the equation of the circle? All right, well, we know that the equation of a circle looks like this. X minus h squared plus y minus k squared equals r squared. H and k are the coordinates of the center, r is the radius. All right, so the coordinates of my center, all right, 20 feet east and 40 foot north, so 20 and 40. So I'm going to write x minus 20 squared plus y minus 40 squared, and then radius is 60 squared. All right, so x minus 20 squared plus y minus 40 squared equals 3600. Right. So this is a good form for the equation. Don't try to expand it out unless you need to. I'm kind of leave it like that for now. All right, so let's find those intersection points, the horizontal line crossing the circle. So the horizontal line is y is 0. Okay, so take these together. You want to plug in. So you want to plug in y is 0 into the equation. When you plug equations into each other, you're finding where they intersect. All right? So we're going to have x minus 20 squared plus negative 40 squared is 3600. X minus 20 squared plus 1600 equals 3600. Subtract 1600, x minus 20 squared equals 2000. Take the square root of both sides with the plus or minus. Okay, there are two there's two intersection points just looking at your picture, so you need to take a positive and negative square roots. So x minus 20 equals positive and negative square root of 2000. All right, so plus or minus 44.72. Add 20 to both sides, so we have x is 20 plus 44.72, which is 64.72, or x equals 20 minus 44.72, negative 24.72. All right, so this tells us this value here is negative 24.72, and that value here is 64.72. So what portion of the street is illuminated? You can say from, in math, you can give this as an inequality or an interval notation. You can say negative 24.72 less than or equal to x less than or equal to 64.72, or you can say interval notation like this. Okay? Alright, cool. Now let's do the y-axis. So now we want to figure out what portion of the y-axis is illuminated. We go back to our circle equation, x minus 20 squared plus y minus 40 squared equals 3600. But now we want to plug in x is 0, right? Because we want to see where the vertical line crosses the circle. So we plug in x is 0. We have negative 20 squared plus y minus 40 squared equals 3600. 400 plus y minus 40 squared is 3600. Y minus 40 squared equals 3200. Take the square root of both sides without plus or minus square root. Plus or minus square root of 3200. Y minus 40 equals 56.57. Alright, add 40 to both sides, we get y is 40 plus 56.57, which is 96.57. Y is 40 minus 56.57, which is negative 16.57. So the portion of the y-axis that's illuminated is in the interval from negative 16.57 to 96.57. Right, going back to our picture. So this one right here is the negative 16.57, and this one up here is 96.57. Alright, there we go. So that's it for the examples related to this problem set 2. Alright, have fun with them.